Hello guys, how are you? So today I'm just going to talk with you transformer architectures, as there are so many videos available on the nets or on the YouTube, and there are so many blogs or articles written related to the transformers, and there are so many also papers published, but so many of you are facing the difficulty while understanding what is transformer, how actually it's working behind the ChatGPT models or any Google's models, or there are so many models. So I'm just going to explain overview and quick understanding of the transformers, as it's the came next to the LSTM models and networks, and which have a very huge capability to understand the context. While LSTM networks will not going to process the data parallelly, but transformer model will going to take the data parallelly, and that's the huge advantages for the transformer models. And at a time they have a cell potential head, and they do not contain only single cell potential head, but they containing the multi-head cell potentials. And many of you will going to face the challenge what is actually cell partition and how it works. And for the cell partitions there are some matrices like key, query and values, and so many of you face the difficulties exactly what are the keys, how those values generated, what are the queries, and how their matrix multiplication happening, how dot product is happening, and how many layers it's containing, which layers it's passing, and all those. So see that transformer mainly consists of two parts, encoder and decoder parts, and both of each that encoder and decoders have a self attention or multi-head attention mechanism. So multi-head attention is nothing but the if there is more than one self attention, then it's become the part of multi-head attentions. And why we require the multi-head attentions? Multi-head attentions required because sometimes only a single head attentions may be going to forget that some context while seeing the context or large context. So that time those multi-head attentions plays the important roles. Now we will going to see the differences between what are the keys, queries and values. So those are the matrices generated by the transformers, which have the shape of how much you are passing the input sequence length. So each transformer has some basic input sequence lengths, such as maximum sequence lengths. Beyond that they will not going to take your inputs, because they have a issue related to the quadratic compute power issue. So based upon the sequence length and what are which tokenizer you are utilizing, based upon that matrices shape will be determined. Such as for BERT model, suppose if your input length is 128 tokens and word embeddings are 768, so those matrices will be 128 into 768 dimension. And how those matrices are generated? See, while passing those tokens have some vectors embeddings based upon how you are converting those words to the embeddings, like word face tokenizer also going to give the embeddings for each word or each tokens based upon the pre-built library. So already those tokens have the some embeddings and some meanings, but when we are passing through those position encoding, that time those matrices will going to get some numbers positions, because transform model will not going to understand those positions. And after that passing positions encoding, then three projections are generated like key, queries and values. So those are nothing but keys, queries and values, nothing but the queries means the current word where we are searching. Then keys are nothing but the words, how one word is related to the other words relations, and values are nothing but the embeddings of those words as we have initially passed. And what happens, so model will try to learn based upon those context. If it will going to see that whatever current word we are searching, is it relevant to the other words, and their dot products is happening, and at the last we are applying some softmax, and after softmaxing all those values we are once again multiplying by the values matrix. So at the last we will get the most relevant word or most important scores. So that's the some magic happening in the transformer. There are so many layers like feed forward networks, then uh, cell point head attention, I have add and normalization regression layer, and so many people don't know about that add and normalization layer, what actually that layer does. But that layer helps to preserve the information when there are so many self-head attention layers, or there are so many encoder box tags. You know, in the bird based on case model there are 16 or 12 layers or 6 layers of encoders are stacks over one over the another. So to preserve the information, that for that purpose that add and normalization regulation here is required. As you know that how ResNet model is residual network connections in which that information is preserved. Same type of information is preserved in that way add and normalization layer. So and in the decoder same things happening, but there are some basic differences, like decoder will going to take sequence means one token after another, means it will going to feed the output of the previous token to the next one, and it will not going to save all those contexts. And in the decoder there is one extra here, that mask multi-head attention layer, to prevent the model from seeing the right side context. And yeah, they also utilizing a different like means encoder type model, but utilizing word precise tokenizer, and decoder type model utilizing byte pair encoding tokenizers. So there are so many differences, but those are the some simple things. And while remembering all, you should must remember what is input embedding, position embedding, tokenizers, key queries values, their dot products, multi-head attention, and all those. So I'm going to create another next video, and in that I will going to show all those details. If you have any doubt or questions, please try to ask me in the comments. And have a nice day. Thank you. Bye bye.